This style of quiz is typically rather difficult for students to complete because you really have to know the content in order to correctly answer the question. For each one of these questions, 1 through 9, you're going to respond with the number associated with the element in this list. But notice it says of the corresponding elements, so you could have one answer or you could have multiple answers. You could also theoretically have no answer. I didn't do that on the practice quiz nor on the first two versions of the quiz, but if you happen to be absent, the third version could very likely have a no answer question. So let's look at some of these questions. We're definitely going to need our periodic table, and probably you'll also want table S. So the first question says, which element has the largest radius? The radius is just the atomic radius, which you could get in table S in this very last column. So you can look that number up for each of the elements. To make it a little easier though, I would suggest you look up the atomic number for each of those elements first, because table S is arranged a little different than the periodic table. It might be more difficult for you to find it without first knowing the atomic number. Element K is actually element number 19 right here, so I'm going to write in the atomic number off to the side here. It'll actually make it easier for me to look up in table S. CS is right here, it's element number 55. CR is over here, it's element number 24. And again, you don't necessarily have to do this, but I think it's going to make your life easier. Lithium is right here, element number 3. Si is silicon, it's element number 14. And oxygen, O, is right here, it's element number 8. So I'm going to put this away for a minute. So the largest radius, I'm going to pull out table S, and we can actually record all the radii. So we have element 19 here, and all the way across its radius is 200. So I'm just going to jot that down right here. And it doesn't matter how messy your paper gets. Cesium, we looked that up, that was element number 55, so I need the second half of table S to find that one. And then I might tuck it away because I won't need it again. So 55 is 238. 238. Chromium 24 was 130. Lithium, which was number 3, is 130. Oh, those are tied, but they're certainly not the highest. Silicon was 14, and it's 114. And oxygen, which was 8, is 64. So the one with the largest radius is actually cesium, which is labeled with a 2. Another way you could answer this question, and my preferred method, is by remembering the trends. If you remember, as you go down a group, you're adding a principal energy level. So whichever element is lowest in the periodic table, or in the highest period, would actually have the largest atomic radius, and the rest of them are all in period 4 or higher or above that, so it would have had to have been cesium. Next one, which element is not conductive and is brittle? That is describing nonmetals. So we just need to look at our list and decide which is a nonmetal. Well, potassium's a metal, cesium's a metal, chromium's a metal, lithium's a metal, silicon is right here on the edge. Technically, if we were just talking about metal versus nonmetal, I would call that a nonmetal, and then oxygen right here is a nonmetal. What's making me not answer silicon as the answer is because it says it's not conductive. And you may recall we mentioned that silicon is actually used in computers because it is conductive. And that's because of where it is on the periodic table. It's right there at that cusp. It's one of our semi-metals or metalloids. So for this one, I'm just going to answer element 6, or oxygen. Which elements are in group 6? Group is the columns. And if you ever forget that, that is labeled in several places on your periodic table. So we need to find group 6 right here. We only have 4 choices: chromium, I think that's montanium, tungsten, I don't even know what Sg is. So those elements would be in group 6, and we only have one of those in our list, and it's number 3. I'm going to move this stuff up a little. Which element has the smallest radius? Well, it's a good thing I wrote down all those radii. Now I can look at them. My smallest one was oxygen, number 6. Which elements tend to lose electrons when they react? The ones that tend to lose are the metals. Metals, it would be easier to lose to get that full valence shell, where nonmetals would tend to gain. So we need to pick out all of our metals. We just called potassium, cesium, chromium, and lithium all metals. So those ones, being that they're all on this side of the periodic table, are metals and therefore would lose electrons. Which elements exhibit both metal and non-metal properties? These would be our metalloids, or our semimetals. And we identified those as boron, silicon, germanium, arsenic, antimony, and tellurium. Essentially the ones that sit on or below each of the steps in our staircase, with the exception of aluminum. And I'm sure you've had lots of experience with aluminum in your life. You know that aluminum is definitely a metal. It doesn't exhibit any non-metal characteristics other than it's kind of light. So this one is a metal, even though it's below the stairs. All the rest of them above and below the stairs are actually metalloids. We don't include polonium just because that starts where all the radioactive elements are. So when we talk about all of the characteristics of elements, we kind of leave out the radioactive ones. It's hard to study those characteristics because they don't really stay that element. All right, so our answer to that one is going to be silicon, which was choice 5. Number 7, which elements form an ionic radius that's larger than their atomic radius? Atomic radius is the size when it's just a neutral atom. Ionic is when it's either gained or lost electrons. Since they're saying it got larger, it must have gained electrons in order to become an ion, and the elements that do that are nonmetals. This time we're going to include silicon along with oxygen because they are nonmetals in that regard. 5 and 6. Which elements are in the 4th period? The period is the rows. And if you forget that, it's actually labeled right here. I wish it was labeled along here, but it's labeled right here. So the rows, here's the 4th period, and we look across and we actually have 2 from our list. We have potassium and we have chromium, which when we look back up there, they're number 1 and 3. Next question, which element in period 4 has the greatest metallic character? Well, when we talk about metallic character or reactivity of metals, we're looking for the lowest ionization energy. You need to memorize that. So we said the 2 elements in period 4 were element 1 and element 3. So potassium and chromium. So we're going to look up the ionization energies for potassium and chromium. Potassium, the ionization energy is 419. Chromium, it is 653. We said we were looking for the lower ionization energy, so that would be potassium. And that was element number 1. Another way you could look at this is by looking at the group that potassium is in. So we were comparing potassium with chromium. We had said earlier on in the notes that these two groups, the alkali and the alkaline earth metals, are the most reactive metals. So chromium, being a transition element, wouldn't be as reactive and therefore wouldn't have as much metallic character. Now we're done with the questions dealing with those elements listed at the top, and we can look at the trends. And these are all going to be graphs like you've seen in the notes. So the first one on the graph below, draw a line which best represents the trend in ionization energy within a group. We can actually look up these numbers. So I'm going to pick a group. I'm going to pick group 2, and their elements 4, 12, 20, 38, that should be enough to see a trend. And now I'm going to look up those ionization energies in table S. Element 4, it's 900. Element 12, it is 738. I don't want to stop there just in case you've seen some anomalies so you know that it isn't always perfect. Element 20 is 590. Does appear to be going down. One more just to seal the deal here. Element 38 is 549. So it does appear to be going down as the atomic number increases, so we're going to draw a downward trend. All right, next one, draw a line which best represents the trend in atomic radius, again within a group. So this is something we can look up. I'm going to do the same elements again, not that we always have to. Should see the same trend. I would just avoid transition metals for most of these. So we're looking for atomic radius. Number 4 is 99. Number 12 is 140. Number 20 is 174. Does appear to be going up. One more to seal the deal, and it's 190. So yes, it does appear to be increasing, and that makes a lot of sense because as you're going down a group with each element, as you go down, you're adding a principal energy level or a ring around that nucleus. When you go to study this side of your practice quiz, what you're going to want to do is either switch out the elements that you've been given and attempt to answer the same questions, or switch them out and change something in the question. Maybe instead of largest radius, you're going to look for smallest. Instead of not conductive and brittle, maybe you're looking for conductive and bendable. Maybe instead of group 6, you're looking for group 2. So that's how you would study for this quiz and practice. On to the back side. The back side of this quiz includes a few questions that also refer to a list at the top of the elements. These ones are going to focus more on the things that we learned in the chemical families notes. Not that it's exclusive to that, but I used to offer this as 2 separate quizzes. It seemed to pull down students' averages quite a bit because of the style of this quiz, so I limited the number of quizzes we have based on this now. Before we start answering questions, you may want to again record the atomic number of each of the elements, so it'll be a little easier for you to find each of them. Element F is element number 9. Kr is way over here, it's element 36. Ooh, it's hard to write at this point. Element Al is element 13. Carbon, element 6. Nickel is element 28. And strontium is element 38. The more you look these up yourself, the more you'll get familiar with the table and you'll be able to do it quicker. All right, first question, which element exists as monatomic molecules? Monatomic means one atom in the molecule. They aren't going to form bonds with anything in order to be a molecule. They're really quite happy just being by themselves. They form no natural compounds, and that's all describing our noble gases. The noble gases are in group 18 here. The only element from our list that's in group 18 is krypton, or number 2 from our list. Next question, which metal can only be attained by electrolysis of its salts? So we talked about how group 1, group 2, and group 17 are never found pure in nature, where noble gases are always pure. Elements in group 1, group 2, and group 17 are never found pure. The only way that you can get them is by doing electrolysis of their salts. So this actually limited it to metals, meaning that we're going to exclude group 17. So we're looking for group 1 or 2. And the way I worded the question might give you an idea that there's only one element in our list like that. So fluorine is over here, krypton over here, aluminum over here, carbon over here, my goodness, nickel over here. Let's hope strontium, there it is. Strontium is in group 2, it's an alkaline earth. It's the only one that's a group 1 or 2. Number 14, which element often has multiple oxidation states and often forms colored compounds? That is describing transition elements. Transition elements are found in groups 3 through 11. Having looked at the same elements a few times now, you may realize the only element that's in the transition metals is nickel, or the element we labeled number 5. Next question, which element is a member of the halogen family? You need to recall that that's group 17. That's the last group before the noble gases. These are the most reactive nonmetals, and they have their own name. They're the halogens. The only one from our list that's a halogen is fluorine, which we have labeled as element 1. Number 16, which elements are gases at room temperature? You were supposed to color code a key for your periodic table to remind yourself which ones are. But in case you haven't memorized it yet, they're hydrogen, nitrogen, oxygen, fluorine, chlorine, and then all of the noble gases. They're all gases at room temperature. So we actually have more than one that are gases in our list. We have fluorine and we have krypton, which is a noble gas. So these two here. So number 1 and number 2 are both noble gases. Next question, which element is the most reactive metal? Well, you could memorize that metals have low ionization energies and then look up all of them and find the one with the lowest ionization energy. But since we're talking about chemical families, you could look at the fact that we know that the alkali metals are the most reactive, and then the alkaline earth would be the second most reactive. So from our list, we only identified one in the alkaline earth and none in the alkali. So strontium is our most reactive metal. And then in number 18, it's also asking for the alkaline earth, which are group 2, which we just said strontium was a member of. Number 19, which element could be represented by the electron dot diagram shown? It has 2 valence electrons, so we need to look at all of our elements on our list and see which ones have 2 for a valence number. Fluorine has a 7, krypton has an 8, aluminum has a 3, carbon has 4, nickel has 2, so that's definitely going to be one of our answers. And then strontium, which is in group 2, also has a 2. So there's actually 2 answers for that one. And then the very last one, which metallic elements would form a chloride with the formula XCl2? In order to figure this out, you need to remember that chlorine would have to be negative, and therefore it must be -1. There are 2 of them for a total of -2. This whole compound has to total 0. That's the point in bonding. So X must be +2. So we need to find all of the elements from our list above that are, by the way, it says metals, that are metals and have an oxidation number of +2. So we can eliminate fluorine, we can eliminate krypton right away. They're not metals. Aluminum is a metal, but its oxidation number is 3. Carbon's not a metal, we can ignore it. Nickel has a +2, and so does strontium. So once again, our answer is going to be 5 and 6. When you study for the back side, switch out the elements, and you can also switch out what's in the question. Instead of asking which elements exist as monatomic, maybe make it diatomic. Instead of metals, make it nonmetals. Number 14, I really can't change, so make sure you know which elements are transition elements. Maybe instead of the halogen family, we ask the noble gases, or transition elements, or alkali metals, or alkaline earth. Remember, you need to memorize all of those families. So that's how you can practice and be prepared for one of the hardest quizzes of the year.